Awesome, thank you so much. So yeah, we're going to be going over engineering the future, real-time vector-powered analytics with ClickHouse. And really quick, raise of hands, who came to my talk yesterday? Okay, pretty much most of the room. So you guys remember the final question was about how we use ClickHouse with AI, basically how in the future we're going to kind of take real-time data warehousing and feed into AI chat agents. So I'm going to kind of show how we actually did that ourselves. So really quick, okay, does it need to be a little, okay, thanks. Developer advocate at ClickHouse. I've been working in databases for 6+ years, love open source. I already went over all this yesterday. So we're going to go how our customers use ClickHouse to power their own AI tooling, how we built our own chat agent, basically putting our money where our mouth is, the ClickHouse MCP server, which kind of powers a lot of everything I'm going to be talking about, and how our own customers use us, in particular, OpenAI and Anthropic. So what is ClickHouse? It is an open source column or OLAP DB. It's good for blazing fast analytics with massive volumes of data, which in the AI space is pretty much the base requirement. Speaks SQL fluently, which is great. We're good at processing, high efficient storage, easily scalable to any size. So there's 4 different main use cases. Real-time analytics, that's like our bread and butter without a doubt. That covers many different companies, many different industries. Data lakes and warehouses, which I talked a lot about yesterday, but basically just working either on top of your data lake or being your data lake and warehouse entirely. Observability, which I'm actually going to go into a little bit here, specifically LLM observability. So that's obviously also the observability, things like Kubernetes and otherwise infrastructure monitoring. And then machine learning and Gen AI, where we tend to be in 4 major features. We tend to be a feature store, which I'm going to go into what that is. Vector search, which is pretty much just being a vector database, storing vectorized data. LLM observability, so large language model observability, and AI agents, the actual agent that you can chat with. So these are some of the companies that are already using us for their agentic AI use cases. It's a various here, and I'm going to get into a few of them. Like I said, Anthropic's using us for observability. Sierra's using us to actually power their chatbot. I can't remember everyone's stories because there's so many customers that use us, but these are all documented somewhere on our website. So let's get into how our customers use us. So again, why do they end up using us? So there's really 2 ways that customers end up using us for their AI workloads. One, they're already using ClickHouse for something else. And to be honest, at most companies, and just most people in general, it's better to just use a tool you already know than have to go learn a new tool. So this actually is how we originally were used for AI workloads without really being that great for them. Like about a year or so ago, we were being used by a lot of companies that were already using us for analytics. They started using us as a vector store. And it's not that we couldn't do it. We obviously could because they did it without even asking. But we weren't, well suited for it at the time. We've gone ahead and put in a lot of efficiencies since then. So now we're very good at it. They also used us just because right away they were like, oh, this works. Like they were watching other companies do it and they were like, if they're using ClickHouse for, their AI workloads, why can't we? So that tends to be the 2 ways that people came and found us. So this is kind of a good way to kind of keep track of like what people end up using us for. So we tend to be what we call a feature store. And for anyone who doesn't deal with like machine learning model training, a feature store, I like to call it a database that's been curated. So basically a feature store is where you store the data that you want your ML model to be trained off of. But normally, especially in a business sense, you don't want to put sensitive data in this feature store. So maybe you don't want customers' names or something like that. You also don't want to put what I call poisonous data in this feature store. So for example, I can't remember the story anymore, but somebody bought all the chat history of Reddit, and like that's a lot of poison. You do not want to train your ML model off of all of that. You need to clean it. You need to make sure it's been very pristine, or else you're just gonna end up with an angry, mean like AI agent bot that is like mean to you. Like that's why ChatGPT, for example, doesn't normally get trained off of what you chat with it. Part of it is protection of your own privacy, but part of it's that you could be poison that they don't want in the model. They don't want it to learn from you because maybe you're really mean and they're like, we want ChatGPT to be friendly. If you've ever tried to like argue with ChatGPT, it's very much like, let's be friends with the whole world. And you're like, that's how they did it, is they made sure that it was trained on only niceness, basically. And it's the same thing, like I said, for in a data, like especially in a work setting, you certainly don't want like a mean, nasty chat agent for your actual employees to use, but you also definitely want to make sure like it does not have access to user information necessarily, or if it does, it's only through certain credentials. Like, imagine if you're trying to change a flight and Qantas was telling you about other people on your plane. You're like, this is not what I wanted. This is not cool. So that's what we tend to get used for, is this very specific data set. Basically, it's a curated database that then people train their models on. Model inference is when you now start to add new data onto your feature store, or data that it hasn't seen before, and you want to make sure it actually interacts appropriately when it gets this new data. So you've trained it, you've got it ready, you start doing model inference on it, and you start to make sure that as you give it new data, it responds appropriately and doesn't do like strange things, and that it categorizes them effectively. The other one is data exploration and preparation. That's pretty similar to the feature store. It's just making sure like that's the part where you start to look for, what do I not want in here? What do I want in here? What's appropriate? What's inappropriate? That's pretty much the exploration and preparation. It's just being like, trim it here, add more here, we need more detail here, get rid of this entire conversation, etc. And then finally, vector store, super straightforward. That is straight up vectorization, vectorized data that you just store in ClickHouse. It's basically, if you've ever seen vectorized data, it just looks like a garbly goop of numbers. That's basically what it is. For us, it's like an int 32 data type, basically. And then finally, observability, which is basically making sure that when you do have things like large language models, especially if they are consumer facing, especially if they're things like ChatGPT, you don't get spammed, you don't get attacked, you can handle large workloads. All of these things are very important. So this, for example, is how like weights and biases is using us. For this one, I have the story up here in the QR code so you can grab it. I'm like staring at this now. I'm trying to remember how they're using us here. Yes, so they're using us for the observability use case. So basically they're running a model. I think this one's being run internally for their own employees to take advantage of. And they're just making sure that it's running efficiently, that it's not crashing on anyone, and that just in general, the endpoints are being hit by the appropriate people. It's just the observability you know, and if you work in observability, is the observability you know for infrastructure just put onto large language models. This one is talking about feature store. So as I talked about before, you have lots of data sources that will go into your feature store and metadata. And here that yellow box is to indicate that the feature store is ClickHouse. Then you send it onward to your training platform and pipeline tooling, which I am not going to get into because it's not something that I'm super familiar with, but there's lots of different options depending on how you want to do it. There's, for example, down at the bottom here, you see the inference pipeline, and then that feeds into things like an actual application eventually. So this is kind of how this actually starts to look when you're doing machine learning training. And again, this blog article is very long. It goes in depth on how to do this. Finally, vector similarity. So this is in beta, but basically what this does is it takes vectors, which I was slightly wrong. It's an array float 32 type, and it basically does vector similarity search where you can feed it a vector and you can ask for vectors that are similar to it. So this is really great for vector searching. This is great, obviously, for people who are like, and normally when you see an example of vectorized data, it's always like an image. It's always like an image of a dog or something, and it's like, find me more images of brown dogs. This is basically doing exactly that, just with vectorized data. But again, this blog here talks about how you use it at scale, and it's also using images of dogs to do the example. Because again, imaging this is much easier for people to understand. Technically, it also does it for words too, but the word portion of it is a little more confusing, and images are just so much simpler for us to visually understand. So how do we build our own chat agent? So let's make sure this video actually plays. Let's see if, there we go. So for any of you who have ever played the Fallout 4 games, this should look familiar. But basically what this is showing is how people, for now, interact with the ClickHouse CLI. So basically they're interacting with the database. In this one, they're specifically querying from it. You can see they're doing like a select all from the UK price data. For anyone who joined me for training on Monday, you should recognize this in particular. But basically this is kind of showing off how people have interacted with not only ClickHouse, but many DBs throughout pretty much the beginning of working with databases. So basically this is the old style. That's why it's in this Fallout 4 like forgotten about video pattern here, is to show like this is old, in with the new we go. So also the other thing to note about this used to be how it worked. This is pretty straightforward. You make a query, your user says, why is my thing slow? And it goes to the database and it makes the query and it sends back the insights. Maybe you have some kind of middleware layer if you need it, but for the most part, it's one query, one insight back. Same even with the middle layer. It's one request, one query, and the results just come back through. Maybe the middleware layer does some manipulation to the results that you're getting. Like maybe, for example, it checks authentication, etc. But for the most part, this is how it operates. Nowadays, though, we are going to be having more chat agents that you can interact with. And ours in particular are going to be able to do the queries for you. You aren't going to need to know how to do select all, which, let me be clear here, it doesn't mean that like SQL is invaluable or anything like that, but I'm just saying in the future you won't have to know it as much. The AI agent will be able to do it for you. But with this comes in a very different workload. All of a sudden, it's a lot of queries, especially because, as many of us know who have ever interacted with an AI chat agent, it's not like it says you're only allowed to ask me one question at a time. You can ask it 50 questions if you want. Like, it will probably return you a really weird answer, but you can still ask a ton. Like, you can ask a lot of prompts, you can ask a lot of tasks, and this AI agent is going to hit the database like crazy because it's building an answer for you. So it has to go back and forth and be like, oh, they wanted to know the best time to fly. Okay, I need this flight data, I need this flight data, I need day data, I need weather data. So it's just gonna keep hitting basically and keep expecting results. And if this query takes forever, it's going to slow down the entire process because basically it can't go onward to build this answer that it's building for you until it gets a response back. So basically what we did is we did an example architecture here, and I'm actually going to show off the agent in a video, and I can actually just probably show it on my own laptop here. But basically we took advantage of the MCP ClickHouse server. We've got data in ClickHouse where we are storing basically open data sets, things like the UK price point, taxi data, etc. Not our own internal data. We have a chat agent for that, but this one's consumer facing, so people can take a look at it. And basically we're using Anthropic to go ahead and do the actual chat portion of it. Like, it's the one that's responding nicely, basically. And yeah, let me just go ahead and show you guys the demo. So yeah, this is Agent House. It's live. You can go to llm.clickhouse.com. This is nice in that it's a little bit faster while we watch it here. But yeah, so as you can see, it's telling you what data sets we have available. It's going ahead and running multiple queries here. It also visualizes. So it's also going ahead and visualizing all of the New York City taxi fare and analysis. And so this is really nice. And like I said, I can actually probably just show this really quick because that'll be, oh here, let me make this full screen. llm.clickhouse.com. You'll see some of my old ones that I asked it the other day. Let's see actually if they're all fully loaded. So with this one, we were actually showing a customer basically how they can take advantage of it. So for this, we were asking it to create an analysis of the OTel2 databases, and you can see exactly what it's querying, how it's querying it back, what kind of answers it's getting. And then over here, you can actually see it visualized out as well. And the idea here is that basically you don't have to think about how to, write this out in a SQL query. You can just ask it in a English or hopefully in the future other languages, and then it will just be able to respond back to you. And especially the visualization portion of this is great. It's great to be able to take advantage of. And like I said, it's great when it's really fast. Sometimes it's a little on the slower side. This one's looking at like an analysis of a geotable, for example. One that I did a while back was like the best time to fly Chicago O'Hare to Newark. It's actually really, I wonder if it's still here. For a while, it was telling me the best time was COVID. Apparently, the flights were less delayed during that time period. Let's see if it actually talks about it a little bit. I don't know where it went to, but I laughed so hard when I saw that one. I don't know if it like ate it. But it's got the data all the way from 1987 to 2025. So when I originally ran this, it also took like a couple of minutes because, it's trying to go through all of this data type. But yeah, we have lots of different data that you can go ahead and take a look at here. Like I said, it's really cool. Oh, there it is. It was the ones from Las Vegas to London. And look at that delay percentage during COVID. I also love that it did mark it. It was like, by the way, this is why it's so good right there. But otherwise, I think it told me like the best day was sometime in like the winter or something like that. But yeah, so that's kind of how you can take advantage of that. And so going onward a little bit into LLM observability. So this is a story on how Anthropic uses us to basically take advantage and observe Claude. And so just one thing to note here is that this is a full talk they did at our conference, so it's like 20 minutes, but this is the blog about it. I think it also links to the video. I've got a few of their slides from here. So basically, this is one of their slides where they talked about what do we need. They needed to ingest huge volumes of data. That's not very shocking. It needed to be fast, it needed to be feature-rich, and it needed to be over what they called semi-structured data. Because that's the other thing too, is this kind of observability workload is not as defined as the observability workload on something like a Kubernetes infrastructure or just servers in general. That's relatively structured. We've kind of figured that portion out at this point, but this is basically on the fly observability. You're getting data and you just kind of need to figure it out yourself, and then you need a little bit of flexibility in the data that you're storing. It also needed to be deployed within their secure computing environment, and shockingly they did not want this deployed to cloud, and it had to be a low operational cost for them because otherwise this was going to be really expensive probably. So they ended up deploying ClickHouse. Again, I'm skipping a lot of the slides here, I'm just kind of getting to these two. It was very good at dynamically scaling, it was cost efficient, we were using blob storage, amazing. We gave them basically ClickHouse Cloud, but on an air-gap deployed version on their compute environment, which obviously for most of our customers that's unnecessary and they just use cloud and take advantage of that. But for Anthropic, we went ahead and I guess you could say went all out. And they did require that air-gap deployment. Another one, which this is great in that they're both competing products, OpenAI is also using us to basically also do observability of ChatGPT and making sure that this is good. This story is really fun in that they talk about, remember when you could start to make your images into Ghibli images? Apparently that was a really heavy workload that just crashed everything for them, and the fact that a million people were asking for Ghibli images of their pets. So basically that crashed a lot of stuff, and that really actually put into place, they'd put in all this observability and that kind of tested everything for them. So this is a really fun story, and their deck is really hilarious as it's got a lot of memes of houses on fire, or the dog holding the cup of coffee being everything's all right, as everything's burning around him. That's basically what they were dealing with when this got released. So for them, they were the business problem, they had a bunch of stakeholders, they have to do research on this data, they have ChatGPT, which obviously has viral user growth. They also had enterprise APIs, so those are the people who are actually taking advantage of their APIs. They need to make sure that that's being observed and dealing with incident management, because anyone who's ever worked within enterprise or API ecosystems knows that they are ripe for abuse and spamming. So you need to make sure to keep bad actors out. Why did they choose ClickHouse? Because we were open source. They've actually fed back to the open source with multiple GitHub pull requests and many features that they needed and required. So that was part of the requirement. We need to be open source so they could feed back to meet their own requirements to a certain degree. Horizontally scalable, cloud native. They didn't want to run this on-prem. They wanted cloud. Flexible indexing to support diverse queries. That's basically just another way of saying that we supported the diversity of the data they were bringing in. SQL, they didn't want to learn a new language, and they wanted it battle tested. So they were very happy to see that we had other large customers, some of which I can't mention here publicly, who were already using us for this use case, which they quite enjoyed. This is our own observability that we've put into place for our own chat agent, the one I showed you, the llm.clickhouse.com. Yeah, because it also got attacked, as things do. You put things out in the web and the people are going to have fun. They're going to do what they wish. And so we needed to put our own observability in place. We did this, I want to say a month after it was out in the wild. We had to take it down for a day or two and put it back up after we got this in place. But with this one, it's interesting in that we're actually just doing what I would consider to be more normal observability. We're using our open telemetry collector. We're using ClickStack, which is our new observability workload. Basically, it's going to be something in the future. HyperDX will be within the Cloud UI system, so you can take advantage of it. But yeah, basically, we followed our own customer's lead and put in observability for our own LLM. Though luckily, ours has never had any viral ability. We've never been put down as much as our big customers have been. But still, it was good to be able to see how this would be done in place. And we have a blog about it right here. I'm sorry, I should have put this QR code on that slide, but this is the QR code to actually see how we put into place if you want to do something similar in the future. Because that is one thing that both the ChatGPT, the OpenAI, and the Anthropic stories don't really tell you how to actually build what they built, because it's difficult and proprietary, but we'll tell you how to do it. So that's at least nice. So the ClickHouse MCP server. So for anyone who's not aware, MCP is a model context protocol. It's basically a way for AI applications to connect and use external tools and data sources like ClickHouse. Normally, AI models can only work with the information they were trained on, But MCP basically creates a bridge that lets models reach out and interact with other systems, like I said, DBs, APIs, or even straight up files on your computer. So for example, you could query a company's database to get more current information. You can read files off your own computer. You can actually use it to control smart home devices, which I've never done yet, but that sounds intriguing. And you can access live data, like, for example, stock data or weather data or other data that, for example, with our Flight 1, that's what it's accessing. It's accessing a weather API and it's asking it for current information. That's actually what our own AI chat agent is doing. That's one of the ones it's taking advantage of. So originally we built out an MCP server, I think it was back in like the fall or summer of last year, roughly. Or no, it says right here, January. That's right. So the original one was built out in January. Man, we've moved really quick on this because we already have an MCP part 2. And basically it was a flagship local MCP server. So it was open source. It was available to everybody. We were starting to use it for our own demos, etc. As you can see, the public demos listed here, the llm.clickhouse.com, or as we always just call it, Agent House. It does obviously require infrastructure and a manual setup. It's just an open source MCP server. Nowadays, though, in cloud, this is coming out in like, I want to say the next month or two. It's currently in private preview. We are going to have a fully managed MCP server for ClickHouse Cloud Services, where it will basically be turnkey, hassle-free deployment. You simply enable the MCP from the UI. You'll have OAuth authentication. Obviously, it's built on top of ClickHouse Cloud, where you can use like query APM points and fine-grained access control models, which is really useful. And yeah, it's compatible in general with your favorite MCP services. And as it says here, yeah, it's in private preview. So to kind of show this, let's let this video load in. Yeah, so if you've never seen the ClickHouse Cloud, this is basically what it looks like on the user interface. In the future, you'll be able to kick MCP. For this one, it's going to go ahead and enable the MCP protocol. Great. And for this person, what they're doing for this example is they're just going to run it in like a local project that they've got on a local host. So here they're pulling the MCP data from London price data. That's what's loaded into their database. And now they can go ahead and talk with it just like that. From my data in ClickHouse, what are some good investment opportunities in London? And I find this one really funny in that they ask for cheapest and most expensive. And the fact that I don't think the most expensive neighborhood is going to be the best investment opportunities, but what do I know? And then it will obviously go ahead and call the MCP tool, and it's going to go ahead and start giving you back some information. So very cool, very useful. Basically, it'll allow people to read data that they already have in their own personal database. Basically, they can build their own LLM chat agent. They can build their own agent house in-house and just take advantage of it. It's going onward. It's going to do a few more displays. With this one, they're asking it to give them like a visualization, like basically give me CSS that I can feed in here, and then give it a couple of seconds. This is also obviously a little bit sped up. When this is going at like real time, it can be a little bit slower. I don't know, it depends on how strong your internet is. And yeah, so for this one, it's now added in the CSS for top 10 cheapest bureaus and top 10 most expensive ones. So great, good to see. The next demo is kind of similar in that it's still taking advantage of the MCP agent, but this time we're going to go and use it in Claude. So let's go ahead and watch this roll. Yeah, so with this, they've already loaded it into it. They've already hooked up the MCP server. And so now you can just go ahead and interact with it directly. And one thing to note here is we did use Claude because it already has the capability of writing SQL. So that is one thing to note, is not all chat agents have been trained to basically understand SQL query language or write SQL, but this one in particular has been. So that's actually why we took advantage of it for both these examples as well as for our own LLM chat agent. So yeah, it's going to go ahead and do basically the exact same thing here. It's just going to do it within this environment, so you don't have to create it yourself in your own in your own files. And yeah, it's going to spit out some facts. Basically, this is like, again, a personalized version of what we've already built. Oh no, it won't go forward. No, there we go. We also have recently joined AWS Marketplace as an AI agent and tool categories with our remote MCP server. That's the open source one that we have from originally, obviously. So we're very proud to be joining them on that. It was a great announcement for us. It kind of gave us a little bit of a pat on the back to be like, yes, you're going in the right direction. And let's see, yeah, there we go. So helping our own customers with AI. So you kind of already see this with the MCP server, But to kind of go a little bit deeper, what we're going to soon have is an Ask AI on the side, which unshockingly will just read directly from your database. And the point of this is even more, I guess you could say more advanced in the fact that in the future, we imagine ClickHouse as the kind of place where, yes, you're going to have your database, your data engineers, your people who definitely know SQL, who understand what they're looking at, use it. But we also want it to be more friendly for people who are not in that job, basically, to be able to take advantage of this. Somebody, for example, from your, I don't know, your marketing department would be able to ask questions like this, and they don't need to know how SQL works. All they need to know is that the data that they want answers from are in the database. They just need to know how to ask them, basically, and then they can receive the answers that they want. So again, this is kind of like cutting out the middleman of having to create your own chat agent for your own internal, employees or users, etc., and instead just allowing them possible access to this just directly. And obviously we have things like we have credentials, we have user account controls, so like you could lock stuff down from certain people. It's not like you're giving them access to like all the databases, etc. But that's basically the idea, is that in the future, people who maybe don't know SQL or don't use it in their day-to-day life would be able to take advantage of the DB. So yeah, this is the private preview. Like I talked about before, this is the one that's going to be really on cloud, very focused on our cloud users. And yeah, if you'd love to connect with us, we have a Slack community where you're welcome to ask questions. We have a Sydney meetup group. We have a booth downstairs that has a yellow tablecloth. It's very obvious. We'll be down there for the rest of the evening. And yeah, all of these great use cases. And if you have any questions, please feel free to come up and ask me after the talk. Thank you, guys.